Hello everyone, welcome to Swag Talks. And I'm Shravika, my teammate is Akanksha. We are from Cybersecurity Department. And our topic is first come, first serve process scheduling. We made this presentation under the guidance of Dr. M. Prasad, Associate Professor, Department of CSC. First come, first serve. FCFS stands for first come, first serve. FCFS is an OS scheduling algorithm that executes requests and processes automatically. The OS stores these processes in the form of a queue in order of their arrival. Processes requesting the CPU first get the CPU allocation first in this easy and simple algorithm with the help of a FIFO queue. After entering the ready queue, the PCB of a process links itself with the tail of the queue. Thus, when the CPU becomes free, it is assigned to the process that is at the beginning of the queue. The process that has the least arrival time receives the processor first. FCFS is considered as simplest CPU scheduling algorithm. In FCFS algorithm, the process that requests the CPU first is allocated in the CPU first. The implementation of FCFS algorithm is managed with first in first out queue. FCFS scheduling is non-primitive. Non-primitive means once the CPU has been allocated to a process, the process keeps the CPU until it executes a work or job or task and releases the CPU either by requesting input or output. Now let us know real life example of FCFS scheduling. As a real life example of FCFS scheduling, a counter system of shopping mall can be observed. The first person in the line gets the bill done first, and then the next person gets the chance to get the bill and make payment and so on. If no priority is given to the VIP customers, then the billing system will go on like this. It means the first person in the line will get the bill first, and after finishing the first customer's payment, the counter boy will pay attention to the other customers. As FCFS is non-primitive type, so no priority will be given to the random important task. And another simple real-life example of this algorithm is the cash counter. There is a queue on the counter. The person who arrives first at the counter receives the services first, followed by the second person, then third, and so on. The CPU process also works like this. FCFS scheduling mathematical examples. In CPU scheduling problems, some terms are used while solving the problems. So for conceptual purpose, the terms are discussed as follows. First one is arrival time. Arrival time is the time at which the process arrives in ready queue. Second one is burst time or CPU time of the process. It means the unit of time in which a particular process completes its execution. Completion time. It means at which the process has been terminated. Turnaround time. The total time from arrival time to completion time is known as turnaround time. Turnaround time can be written as turnaround time is equals to completion time minus arrival time, or it is equals to burst time plus waiting time. Here waiting time, it means the time at which the process waits for its allocation while the previous process is in the CPU for execution. Waiting time is equals to turnaround time minus burst time. Response time. It means the time at which the CPU has been allocated to a particular process first time. In case of non-primitive scheduling, generally waiting time and response time is same. Gantt chart. It is a visualization which helps to scheduling and managing particular tasks in a project. It is used while solving scheduling problems for a concept of how the processes are being allocated in different algorithms. Now let us take a mathematical problem. Consider the given table below and find completion time, turnaround time, waiting time and response time, and also average turnaround time and average waiting time. Here 5 processes IDs are given and also their respective arrival time and burst time are also given. For this problem, for first process P1, arrival time is 2 and burst time is 2 and completion time is 13. And for finding turnaround time, we know that turnaround time is completion time minus arrival time. And for solving waiting time, we know that it means turnaround time minus burst time. In process 1, arrival time is 2, burst time is 2 and completion time is 13. So turnaround time is completion time minus arrival time. So 13 minus 2 is equals to 11. And waiting time is turnaround time minus burst time. Here turnaround time is 11 and burst time is 2. So 11 minus 2 is equals to 9. Here waiting time and response time are equal. For second process ID, arrival time is 5 and burst time is 6 and completion time is 19. Turnaround time is 19 minus 5, 14 and waiting time is turnaround time minus burst time. It means 14 minus 6 is equals to 8 and response time is also equal. For third process, arrival time is 5, burst time is 4 and completion time is 4. Turnaround time is 4 minus 0 is equals to 4 and waiting time is 4 minus 4 is equals to 0. And for fourth process, arrival time is equals to 0, burst time is 7 and completion time is 11. So turnaround time is 11 minus 0. It means 11. And waiting time is 11 minus 7. It is 4. It is 4. And the response time is also 4. And for fifth process ID, arrival time is 7, burst time is 4 and completion time is 23. So turnaround time is completion time minus arrival time. It means 23 minus 7 is equals to 16 and waiting time is turnaround time minus burst time. 16 minus 4 is equals to 12 and it is same as response time. Average waiting time is equals to 0 plus 0 plus 2 plus 4 plus 8 and by 5. And we know that it is 2.8 time unit. Now let us know about advantages of FCFS scheduling. It is an easy algorithm. It is an easy algorithm to implement since it does not include any complex way. Every task should be executed simultaneously as it follows FIFO queue. FCFS does not give priority to any random important task first, so it's a fair scheduling. And we know that it is easy to program, works on first come first serve basis, and it is simplest CPU scheduling algorithm. Now let us know about disadvantages of FCFS scheduling. FCFS results in convo effect, which means if a process with higher burst time comes first in the ready queue, Then the processes with lower burst time may get blocked, and that processes with lower burst time may not be able to get the CPU if the higher burst time task takes time to forever. If a process with long burst time comes in the line first, then the other short burst time process have to wait for a long time. So it is not much good as time sharing systems. Since it is non-primitive, it does not release the CPU before it completes its task execution completely. And it is insufficient, high average waiting time, and also may cause starvation if the first job has the longest burst time. And short processes at the back of the queue have to wait for the long processes to finish execution. And now let's discuss about characteristics of FCFS scheduling. It supports both non-primitive and primitive scheduling, executes jobs on the basis of first come first serve, easy to implement and use, poor in performance and has high wait time, and also may cause starvation if the first job has